Hello and welcome to Nikolay's genetics lessons, and today's problem is all humans are of either blood group MN and MN, and these are determined by two alleles. For example, genotype MM would make blood group M, genotype NN would make blood group N, and genotype MN would make a blood group MN because these two alleles are codominant. In one Canadian unit population, there were 320 people of the blood type M, 110 people of blood type N, and 40 people who belong to the blood group MN. And you have to answer 3 questions. As usual, I recommend you to pause video here, try to solve this problem on your own first, and when you would be ready, you can run video again and you can compare your answer with my answer and explanation. So, let me list again all 3 blood types and genotypes. For example, we know that 320 people belong to the blood group M, and this is genotype M. So we have 320 people. We also know that 40 people belong to the blood group MN, so MN, we have 40 people. And we have 110 people who belong to the blood group N, and this is genotype NN. And we have 110 people. If we add all these 3 numbers, we are going to get 470. So total number of people 470. So what we are going to do next? We are going to find frequency of each genotype or blood group here. So we have to divide each number by total number of people. So 470, 470, and 470. And for example, here we are going to get frequency of the blood group M as 0.68, and frequency of the MN blood group would be 0.09, and frequency of the N group would be 0.23. So we got now frequency of the 3 genotypes and frequency of 3 blood groups. So we convert these numbers, absolute numbers, into frequencies. What we are going to do next, we are going to find frequency of the M allele and L allele. If you pay attention, you would find that these 3 genotypes are made by only 2 alleles, allele M and N. So, for example, half of this number is made by allele M, so 50% of the blood group MN would be allele M. So this means that we have to move 1/2 of this number here, and 1/2 would be 0.045. So new frequency is going to be 0.70, so 25. And this is going to be frequency of the M allele, and half of the 9%, 1/2, because 50% of this blood group of this genotype MN are alleles N. So 1/2 would go here, and this is going to be the same 0.045. and this is going to be 0.275, and this is going to be frequency of the allele n. Now take a look what we got. We got frequency of the three genotypes and frequency of three blood groups, and we also got frequency of the M allele and N allele. And also, as you see, all alleles, frequency of the allele M plus frequency of the allele N would make 1 or 100%. And this is true because in this gene pool we have only allele M and only allele N. And if we add these frequencies, we should get 100%. If you didn't get 100%, that means you made a mistake somewhere. And also pay attention that frequency of three genotypes, if we add these numbers, we are also going to get 1 or 100%. And this is also true because we have only three genotypes in this gene pool, and these three genotypes represent 100% of all possible variants. Now let me introduce Hardy Weinberg formula, and here's a formula. So frequency of three genotypes that can be made by two alleles would equal to p squared plus 2pq plus q squared, and all this would equal to 1. So what p squared here stands for? And it stands for genotype, which is M. 2pq stands for the genotype M and N, and q squared stands for genotype N. So we can say also that allele P equals to allele N, and allele Q is the same as as allele M, and allele Q is the same as allele N. In this formula, for example, we can say that instead of P squared, we can put M squared, because M multiplied by M multiplied by itself would be M squared. And for example, Q squared is the same as N multiplied by N. We can put N squared here. And here we can change, instead of 2pq, we can say 2mn. So now it is very easy to find out if, by the way, we already have found an answer for the first question. Let us return, and the question is, what are the frequencies of the alleles M and N? And here's the answer. Here's the frequency of M allele and N allele. Now we will answer the question, is the population in Hardy Weinberg equilibrium? And at the same time we are going to answer the question, if population were to being mating randomly, what blood group frequencies would be observed in the next generation. And these two questions are connected, because what we call that population are in Hardy Weinberg, that means that generation after generation these frequencies of three genotypes would be the same. Then we can say that this population is in Hardy Weinberg equilibrium, so no changes from generation to generation. But if we would see changes, we can say that this population is not in Hardy Weinberg, it is not in equilibrium, and probably there are some factors such as non-random mating or migration or mutation or some other factors involved that influence frequency of these three genotypes. It also can be a fitness. For example, if one genotype would be more fit than other genotypes, so for example, people who belong to one of these genotypes would have more success in matings, would have more progeny, but as you know, blood group doesn't have such effect, so there have to be different explanation. But anyway, let's now find out what frequencies can be if this group would mate randomly. For example, here we can find frequency. How we are going to do it? We know the frequency of the n allele, so of course we can find n multiplied by n. This is going to be, let me write down, this is going to be 0.275 squared. Or we also can say that this is going to be 0, so 0.08, and this is what we expect if we would see random mating of these three genotypes with these frequencies. Now let's find frequency of the MM genotype and blood group M. So we just have to square frequency of the M allele, which is 0.725 multiplied by itself, or we have to square this number, and the frequency is going to be 0.52. Now let's find frequency of the heterozygous genotype. So we are going to have one more time 2 multiplied by frequency of the P allele, which is 0.725, and by frequency of the N allele, which is 0.275. And we are going to get frequency of this genotype, which is going to be 0.4. And as you see, if we add all these three frequencies, again we are going to get 1 or 100%. Now let's compare 0.52 and 0.68 that we got from these numbers, and this gives us information that numbers are very different. For example, for heterozygous genotype we have frequency of 9%, and here we have frequency of 40%. Here we have frequency of the blood group N as 23%, and here we have frequency as 8%. So here's the answer for the second question. This population is not in Hardy Weinberg equilibrium or balance, and once again we by solving this problem also solved what predicted frequencies should be in the next generation if this population would mate randomly. This is going to be expected frequencies and ratios of the genotypes in the next generation. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. Share this video with your classmates, and see you in the next video. Goodbye.